In this video we are going to talk about how to know what track width to use for signals on your PCB. And I will also show you a simple but very useful trick that can make routing your boards much easier. Let's get started. So, how do we know what track width we should use? There are different types of tracks on PCB, but in most projects the most common ones are digital signal tracks. And usually these are routed with 50 ohm impedance. Notice, I didn't say mils or millimeters. I said impedance. So what's the track width for 50 ohms? Very good question. Here is a simple answer. We can calculate it. If we know the target impedance, the layer thickness and the material of the PCB, we can find the correct width. I often use a free tool called Saturn PCB Toolkit. It's really helpful. You can just choose if the track is on the top, bottom or inside the PCB, add the layer thickness and material, and the software gives you the result. Now, this is very important. These calculations are only correct if the layer next to your signal is a solid copper plane. That means no tracks on the layer, just full of copper. We call this a reference plane. So when you design your PCB, make sure you have some layers just for this, solid planes only. If you are not sure where to connect them, then connect them to ground. If you want to understand more about reference planes and how signals move through a PCB, I made other videos on this topic. Feel free to check them out. Now, here is one more thing to remember. The track width you calculate is just a starting point. In real life, the final numbers may be a little bit different. Why? Because the PCB manufacturing process can change things a little. For example, when the PCB is pressed and heated, the layer thickness can change, and that changes the impedance too. So, if possible, always ask your PCB manufacturer to give you the exact track width for your board and impedance. But here is a problem. Sometimes it's hard to get the track width information from manufacturer. It can take days or weeks, or it may not be even possible to get this information. So I use a simple trick. If I know I will need 50 ohm tracks, but I don't know the exact width yet, I just start routing with wider tracks than needed. For example, in my past projects, 50 ohm tracks were usually around 6 mils or 0.15 millimeters. So instead of using 6 mils, I just start with 10 mils, 0.25 millimeter, or maybe 8 mils, 0.2 millimeter, if I don't have much space. This method has few big advantages. First, you can start your layout right away, even if you don't know the final track width yet. Second, if later you switch PCB manufacturer or change this stack up, it's easy to adjust the track width. And third, when you make tracks narrower, the gap between them becomes bigger, which helps reduce crosstalk and improve signal quality. So, how do you do this? It's simple. Use a unique track width for your 50 ohm signals, for example, 10 mils. After the layout is done, just select all those tracks and change the width to the final one, the value you get from the manufacturer or from your calculation. You can use the same idea for differential pairs. Just use a default track width and spacing. So you reserve the space, and later, when you know the real numbers, adjust them. With differential pairs, it's a little bit more complicated. You may need to reroute them, but that's okay. You get the idea. Now, the power tracks. Be very careful with power tracks. Do not use the same width as signal tracks. If you later make your signal tracks smaller, you don't want to make power tracks smaller too. So what I do is this. If my signal tracks are 10 mils, I make my power tracks just a little bit wider, let's say 10.1 mils. That way, when I select and change all 10 mil signal tracks later, then the power tracks stay the same. If you are not sure how wide your power track should be, you can again use Saturn PCB Toolkit. And what about analog signals? This can be tricky and it's not really my area. In my designs I often use wider tracks for analog to keep the impedance lower, but if you know more about this, please leave a comment and share your experience. That's all for this video. I hope it was helpful. If you would like to learn more about electronics and board design, check out our online courses. You will find everything important there, from basic board design up to advanced board design and high-speed PCB layout. We have courses in Altium, Cadence, KeyCut, and also courses covering many different topics, for example, FPGA, EMC measurements, and so on. Visit our website at fedevel.com. That's all for this video. Thank you very much for watching, and don't forget to leave your comments. See you in the next video. Bye!